So yeah, but we don't want to have to do that by hand all the time, so what we do, now this is a warning. In Excel there is a function called FV, future value, but it is the future value of an annuity, which we will be talking about next lecture, which is next Thursday. We do not use that FV function for a simple future value of one cash flow. So that's what we're talking about at the moment, is a single cash flow, and we want the future value of it. So, say I've got here my present value, interest rate, number of periods, and then this one here is the compounding period, so that's the 12. So what would our formula in B6 be? Okay, well it's going to be, we've got our formula here, so the future value equals present value times 1 plus I to the n. So our formula is going to be equals, PV is in B2, and then before the bracket we need a times, open bracket, 1 plus, interest rate is 0.06 divided by, oops, can't have that. So what have we got here? We've got B3 divided by B5, and that's all to the power of, so that's a little hat thing, and again we need to put brackets around our to power of, so it's not going to work, and so that's B4 times B5. Okay, so that's the formula that should be in that particular cell. That is if we are making a model. Now, often we aren't making a model, we're just using a spreadsheet as a calculator, and I'll come to that in a minute. Okay, so that's future value. What is more use to us is present value, which not surprisingly is the opposite of future value. If you remember back on slide 2, I said, what would you need to deposit now in order to have $1,100 in the bank in 2 years' time? And that is the essence of present value. It's saying what amount of money now at a certain interest rate is worth the same as a certain amount of money in the future. So not surprisingly, the formula, can you just stop talking? The formula is just the other thing rearranged, and we all know how to rearrange now. So we have present value as the future value divided by 1 plus I to the end. Okay, so we want to have $5,000 available in 4 years' time. How much money do you need to deposit now at 6% compounded annually to get that? Okay, so what's 5,000 out of those things? What is it? That's the future value. Good. So future value equals 5,000. Our interest rate equals 6% again. Annually, so we don't need to worry about anything else. And number of periods equals 4. So our present value is going to be equal to $5,000 divided by 1 plus 0.06 to the power of 4. And that comes to $3,960.47. Okay, and how we would read that is we would say the present value of $5,000 in 4 years' time at 6% interest is $3,960.47. So what that means in practical terms is that if we put this amount of money in the bank at 6% for 4 years, we would end up with $5,000 at the end. So apart from the other aspects of money now being more fun and less risky and so on, if I had offered this now or this in 4 years' time, you should be indifferent because financially at 6% they are the same. However, there are other aspects, which is what we've been talking about as well.